Hello, let's continue our Sudoku adventure with Approximately by Strosahl. So this is continuing our Adventure 1000 celebration, I should say. And so each puzzle during the celebration is inspired by an earlier Sudoku adventure puzzle. So Strosahl was inspired by puzzle 507, Approximation by Teal. He says he's a sucker for a good killer Sudoku with ambiguity and also enjoyed the odd-even clues that didn't immediately give away parody coloring. All right, well, let's go over the rules. We have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these killer cages in the grid. The digits in the cage sum to approximately the value in the top left. By approximately, we exactly mean it is within 1. So this cage could add to 9, 10, or 11. This cage could add to 8, 9, or 10. It's within 1, not exactly 1 away. It's just within 1. And then we also have these squares in the grid. Those are even. The way I remember that is squares have an even number of sides. And there's circles in the grid. Those are odd. Remember that is they look like O's for odd. And that is it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. Well, I am not ashamed to just color these. I'm going to use blue for even and orange for odd. Now, what do we do with this information? I'm noticing some things about this grid. We have a 10 clue, a 10 clue, and a 9 clue up here. Those are pretty big. We know that these 10 clues have to, at least one of them isn't a 10, because 10 can only be added to with 4, 6, and so this wouldn't work. But that doesn't mean much to me. We just know one of these at least is actually an odd sum, a 9 or an 11. What else can I say? The 4 clue, 3, 4, or 5. 10 clues are 9, 10, or 11. It feels like something to use later. Like we don't quite have enough information to use that yet. So what about the evens and odds we're given? Okay, so one thing I'm noticing is this row has 2 evens and this row has 2 odds. Let's start with this top row here. So we only have 1 more even in the row. 2 of them are used outside of these cages. So one of these evens will plop into one of these cages with an odd, but the other one is going to be 2 odds. I don't know which way, but whichever one is 2 odds will make the sum correct because 2 odds sum to an even number always. And so if this sums to an even number, it has to be 6 because 5 and 7 aren't. That's just kind of how these cages work. So one of these cages is correct. So let's think about the case where this is correct. It would be a 1-3 pair. And then this would be wrong. It would add to either 5 or 7. Now it couldn't add to 5 because 1, 4 is gone and 2, 3 is gone. So it would add to 7. It could not be 1, 6. In fact, it would add to 7 using the 5, right? Because we used up the 1 and the 3. So it would have to be 2, 5. That's probably the easy way to think about it. It has the other odd in it. So it would have to have the 5 in it. All right. So I'm gonna remember this by just putting it right above. I don't mean that these cells are that option. I just remembering it for a second. Scratch space. So the other option is this 6 is correct, and it has to use 2 odds to be correct. So it has to be 1, 5. 2, 4 doesn't work. Too many evens in the row. So 1, 5. So this always has a 5 in it is the first thing I'm noticing, and it's only ever 1, 2, 5. Now, if this was 1, 5, let's actually not fill that yet. So if this was 1, 5, this has to have the 3 in it. So it couldn't add to 3. It would add to 5. It would be 2, 3. So this always has the 3 in it. And these are our options. Okay. So where are the 4 and the 6? These are the 4 and the 6. All right. Let's think about this row. You know what? The first thing I'm noticing about this row is where's the 6? Because I was thinking about how 5 cage is small. The 5 cage can't have the 6 in it. And the odd numbers aren't 6. Like even if it's added to 6, you can't do 6, 0. So 6 is in this 7 cage over here because of the row, which means that we actually know this is 4, this is 6, for what it's worth. I kind of want to think about how this 4 affects this 10 cage before I think about this row, because I hate case checking. Yeah, let's think about this first, because 4 is interesting. It means we're no longer 10. It can't be 4, 6. We could be 11 with 5, 6. Or we could be 9, but we wouldn't be 4, 5. We'd be 3, 6. So this is only ever 3, 5, or 6. And it has to have a 6 in it, which means this is a 6. All right. And that leaves 1, 2, 3, 5 here, I suppose. But what can this actually be? 6 plus 1 would be 7. 6 plus 2 would be 8. That's it. All right, so let's think about those two cases. So that means that this always has the other two evens. No, sorry. If this was 1, 6, this has to have the other two evens in it. It would be 2, 4. If this was, so 2, 4 is one of the options. If this was 2, 6, then this has to have a 4 in it and the other odd, so it would be 1, 4. So this is 1, 2, 4 and always has the 4 in it. Which means this is 3, 5. Where do the 3, 5 go? They go here. Oh, but the 3's tell us that that's 5 and that's 3. And the 5's tell us the same thing. All right, so I just got some more digits. This 6 looking down, these can't be 6. Can't put a 6 in a 4 cage. Even approximate 4 cage. So the 6 goes here. Can't put a 6 in approximate 5 cage, so the 6 goes here. I think looking at 6s is important. 6 is somewhere in this 9 cage. So the only 6s we have left are in this rectangle. Okay. So then this 10 cage doesn't have a 6 in it. So it can't be 10 or 11. It's not 4, 6, or 5, 6. So it has to be 4, 5 adding to 9. That's 4, that's 5. So that's even and that's odd. So no 5 in here. Not that that matters. All right, this isn't a 5. What else can we do? This is 1, 2, 3 for the column. Whoopsie. 1, 2, 3 for the column. This is 2 or... Oh, it's not a 6. It has to be a 2. So these aren't 2s. What are we doing here? I was going to say there's no 5 in the 5 cage, but it actually could be 1, 5 adding to 6. I was going to place a 5 there, but that would be wrong. What do I think about next? This is from 1, 2, 3, 4, because it can't be bigger than 5 some. Okay, I think I got to take a step back. What have we learned recently that I can use? That was a big flurry of digits. I guess the only thing I haven't really thought about is this column. Can we think about it? We know the 6 is up here. So what does this actually add to? It could add to 8, 9, or 10. Okay, so if it added to 8, we'd be 2, 6. It's kind of interesting. It would be the 2 here with the 6 here. If we added to 9, we'd be 3, 6, but we can't use the 3. Oh, so this is always even. Both are even. This is 2 or 4, and this is always the 6. And that resolves the 6. Let me explain that a little further. Sorry, that was a jump. It doesn't add to 9 because there's no 3. So it adds to 8 or 10, and it has a 6 in it, which is even. So the other one has to be even. So they're both even. And so then it's a 6 with a 2 or a 4, but this top one can't be 2 or 4. If it's even, it's a 6. That makes this 2 or 4. And that makes this a 3, odd. This is also odd, and it's a 1. Makes this 1, this is odd. 3 in the corner is celebrating, by the way. And so now this is a 5, 6 pair. Oh, but this can't be 6. So that's 5. That's right. This had to be the 6. All right. So the 6s are done. That seemed very important. Let's clean all this up. All right. So what does that mean for the 5 cage? Or maybe we should just do this. 2, 3, 4. I think I need more deductions. I don't think this finished. I do need... Let's see, this is 1, 3, 4. So the 4 cage, or is it the 5 cage? Maybe we should think about the 5 cage a little harder. So I'm going to start by writing out 1, 2, 4, 5. That's just what's left for the column. So what if we add it to 4? Well, we can't. No 1, 3. So we don't add to 4. If we add to 5, we have to do 1, 4. And if we add to 6, we could do 1, 5. Oh, if we add to 6, we can't do 2, 4 because that breaks this cell, right? We can't add 2 more evens. We only have 1 more even. So this always has a 1 in it then, because without the 1, I have to use the 5 with a 2 or a 4, which is too big because I can't have 2 evens. And so this does have the 1 in it at the very least, which means it's not 1, 2. 1, 4 or 1, 5 makes sense. Okay, so this can't be 1. This can't be 1, so it's a 3 or 5. Oh, 2 or 4 is even. Do I know what's going on in this row yet? Feels like I should, but... All right, well, let's think a bit more about the consequence here. Yeah, this isn't a 1. Can we not continue from that? What about this 4 cage then? Yeah, so the minimum is 2 3s. That's what it has to be. We can't put a 4 without a 1. So it actually has to 5. 2 3 pair means this is not 2, this is not 3. What do I do with that? Not enough. What haven't I like resolved? Does something up here resolve? Oh, this is a 2 5 pair. Oh, removing the 1 was really important. This can't have a 1 in it. So it adds to 7. It's 2 5, which means that this is 3 1 like this, making it odd. So this has to be an even 2. So this is our 4 and this is our 1. That is to 5. That works. That's not 4. Okay, down here we get the 4 and the 3 and the 2 and the 3. We get the 5 here. This is our 1 and 4. This is 2 and 5. This is 2, 3, and 4. We get the 1 and the 5. Last digit is a 2. And for those who want, I will color the end of this puzzle here. All right. Cool puzzle, Strosahl. Yeah, there were definitely some intricate things to spot, and it seems like the order that we had to solve it was very fixed. But yeah, that was a neat puzzle. Definitely on the difficult side. Let me know how you did, and if you enjoyed this, want to leave a like, subscribe, and a kind comment below.